Today we're going to talk about different types of lines and angles. So vocabulary for today is parallel lines, perpendicular lines, skew lines, parallel planes, transversal, corresponding angles, alternate interior angles, alternate exterior angles, and same-side interior angles. Parallel lines are denoted by two vertical lines that kind of look like railroad tracks. They're coplanar, so they're in the same plane and they do not intersect. So in our figure, AB is parallel to EF, so if you look at line AB in the back and line EF in the front, those are parallel lines, as are EG and FH on the front face of that cube. Perpendicular lines, represented by an upside down T, intersect at 90-degree angles in the figure, and they are AB and AE and EGGH. Notice that both of these share a point. They don't always have to share a point, though. Just in these cases, they actually intersect at a corner. Skew lines are not coplanar. They do not intersect. In our figure here, AB and EG are skew. AB and EG never are going to intersect. They're not parallel. They're not in the same plane. Parallel planes are planes that do not intersect. In our figure, we have plane ABE and plane CDG, which are parallel planes. Segments or rays are parallel, perpendicular, or skew if the lines that contain them are parallel, perpendicular, or skew. So here we have to find a pair of parallel segments. So a good example would be BF or EJ. There are lots of pairs of parallel segments in this diagram, so if you came up with a different one, that's okay. A pair of skew segments, one example would be BF and DE. They are not parallel, but they are never going to intersect. A pair of perpendicular segments would be maybe BF and FJ. BF and FJ make a right angle. And a pair of parallel planes would be FJH, the bottom, and plane BCD, which is the top. So those two are parallel to each other. A transversal is a line that intersects two coplanar lines at two different points. The transversal T and the other two lines R and S form 8 angles. This picture is one of the most common things you will see in geometry both this year and next year. You have two lines and then they're cut by a transversal, which is line T in our picture. There are exterior and interior angles. The interior angles are in the brown area where they're inside the two lines. The exterior are the blue areas where they are outside of the two lines. Corresponding angles are in the same part of the drawing. So 1 and 5 would be corresponding. 3 and 7 would be corresponding. 2 and 6 and 4 and 8. So if you look at the bottom 4 and 5 is in the top left, 1 is also in the top left of the 4 on the top section. Alternate interior angles are on opposite sides and they are both on the interior. So 5 and 4 or 3 and 6 would be examples of alternate interior. Alternate exterior are also on opposite sides, but they are outside. So you have 1 and 8 and 2 and 7 are pairs of exterior angles. Same side interior or consecutive interior angles are on the same side. So 4 and 6 and 3 and 5 would be examples of same side interior angles. Let's look at our picture and give an example of each pair. So for corresponding angles, we could put 1 and 5. We could also put 4 and 8, 2 and 6, or 3 and 7. Any of those pairs would be correct. Alternate interior angles, you could put 3 and 5 or 4 and 6. They're both inside the lines but on opposite sides of the transversal. Alternate exterior angles could be either 1 and 7 or 8 and 2. And same side interior, either 3, 6 or 4, 5. Let's look at another set. Now our picture is turned sideways. So our two lines are facing upwards and the transversal is going from right to left. So some alternate interior or some corresponding angles would be 1 and 3, 2 and 4, 5 and 7, or 6 and 8. Alternate interior angles could be 2 and 7 or 6 and 3. Alternate exterior angles could be 1 and 8 or 4 and 5, and same side interior angles could be 2 and 3 or 6 and 7. To determine which line is the transversal for a given angle pair, locate the line that connects the two vertices. So here we want to identify the transversal and classify each angle. So 1 and 3, we can see that they are going to have a transversal L because vertices of 2 and the vertices of 3 connect at line L, and they are corresponding angles. They're both on the bottom left of that line. For 2 and 6, our transversal is N, and they are alternate interior angles. They're on opposite side of N, and they're both between L and M. For 4 and 6, we have our transversal is M, and we have alternate exterior angles. They're both outside of lines N and L. Go ahead and practice on your lesson quiz. Pause your video, see if you can answer these questions for some practice, and we'll continue on tomorrow with more practice on these concepts.